For this video AI, suppose that in search of companionship, you have an ant farm that you have in your barracks room that you successfully snuck into your barracks room, and after 4 weeks you noticed that the number of ants were increasing in your ant farm. And so each weekend for fun you would count the number of ants and keep track of it in this table. So here we have weeks 4 through 11 and the number of ants you counted per each of these weeks on each of those weekends. And being an MA103 student, you would like to develop a model that predicts the number of ants in your ant farms. And what you really want to know is how many ants you'll have by week 16. So first of all, let's plot this data and decide what kind of a function would best fit this data. So here's our plot, and from here I don't think a linear model would fit this as well as one of our other models. And we could try a power model, but based on the shape of this data, I think an exponential model would probably work best. So if we can decide on exponential, we then have to solve for 3 parameters. Our exponential equation looks like y equals a times b raised to the xth power plus d. And our parameters are these values a, b, and d. And our a parameter represents our vertical stretch. The b parameter represents the shape of our exponential function, and the d parameter is a vertical shift. And to solve for this, we have 3 methods that are outlined. And method 1 and 2, we have to be able to estimate our d parameter, or more appropriately, where our horizontal asymptote lies on our graph. But suppose we are not comfortable estimating the d parameter, and instead that leaves us with method 3. So for method 3, what we have to do is we have to pick 3 representative data points, and from that we have 3 equations to find our 3 unknowns. So looking at the graph, let's suppose that the data point corresponding with week 4, 7, and 11 best represent this data. So with that, we're going to turn to Mathematica to try and solve for what those parameters are. So I'm going to start my solve command, and in the first brackets I'm going to put my equations, in the second brackets my parameters, my a, my b, and my d parameters. And the equation I get from week number 4 is that 19 equals a times b raised to the 4th power plus d. And my second equation comes from week 7, so 40 equals a times b raised to the 7th power plus d. And my final equation comes from week 11, where we have 99 equals a times b raised to the 11th power plus d. And knowing Mathematica, it's going to try to give me every possible solution and the exact solution, unless I specify that I only want real solutions. So I'm going to ask for the reals, and I'm going to ask for a numeric approximation, so I'm going to put that there. Now hold Shift, press Enter, and I'm given 2 answers here. So let's look at this. Let's look at back in the modeling real and complex world. We're given a graph, and our graph is gradually increasing over time. So let's see if there's one that fits one case that fits our model. So looking at this picture here, it seems that case 3 would be most appropriate. And for case 3, we have to have our a value be greater than 0 and a b value be greater than 1. So let's go look at this Mathematica solution. And for this first one, we have an a value that is actually less than 0, and a b value that's less than 1 as well. So I'm going to have to rule out that solution, and instead I'll turn to the second one. And here I have an a value of 10, which is greater than 0, and a b value of 1.23, which is greater than 1. So I'm going to keep this second solution. And I'm going to plot this in Excel in order to be able to determine how well this fits my graph by eyeball test. So here's my predicted number of ants, and this is just going to equal, so my A value is 10.4, my B value is 1.23, and my D value is a -5. And so this predicted value is going to be equaling my A, and I'm going to lock that in, times my B value, and I'm going to lock that in, and that's raised to the xth power, and then plus D. I'm going to lock that in. And I'm going to scroll down and see what my values are. And at this time, I'm going to replot my data here and see how well it fits. So my red boxes here are my predicted values. So I'm going to change the series chart type to be a line. And my line does in fact go through points 4, 7, and 11. It seems like it fits fairly well. But now I want to know how many ants I have at week 16, and by week 16 I should have 280 ants.